All right, let's get right into it. Today, we're going to peel back the curtain on something you probably think is totally set in stone, logic itself. We're diving into a story called Frege's Great Deception. And yeah, it sounds like a spy thriller because in the world of philosophy, it kind of is. We're about to challenge the very foundation of what it means for something to be true. So let's start with a question that really gets to the heart of everything. When you hear a statement, any statement, do you think it just boils down to one of two things? That it's either true or it's false? For more than a century, one of the giants of logic pretty much said, yep, that's it. But what if that simple binary choice isn't the whole story? Not even close.
Now, before we can break the rules, we have to understand them. And that brings us to the classic world of true or false, a world built on one single, really powerful idea, Frege's principle.
So what exactly is Frege's principle? Well, hang with me here. The idea is that what a sentence refers to, what it really points to in the universe, is just its truth value. All the beautiful complexity of a statement, all its nuance, gets squeezed down until its ultimate meaning is just one of two things, the true or the false. If you follow that principle, you end up in a kind of strange place. The sentence, the Earth orbits the sun, a massive astronomical fact, and the sentence grass is green, a simple observation, they basically become the same thing. They're just two different names for the same abstract object, true. All their unique meaning just evaporates. Okay, but what happens when we decide to step outside of that world? This is where our story takes a really dramatic turn. We're moving beyond that simple true-false world to explore something totally different, a fundamental rejection of that core idea.
And look, this isn't some minor tweak or a small disagreement. The non-Fregean approach doesn't just try to fix the principle, it fundamentally rejects it. It's a clean break. It says that the meaning of a sentence is way, way richer than just its truth value. So, what does that look like?
Here is side by side. This is the core difference. On the left, you've got Fregean logic, where every road leads to either true or false. But on the right, non-Fregean logic. Here, a sentence points to its own unique meaning. A proposition, a state of affairs, or what logicians call a semantic correlate. We've just gone from a simple light switch to an entire universe of meanings.
So by throwing out that old limitation, we actually unlock a logic that's way more powerful and expressive. Let's take a look at what this new non-Fregean universe actually lets us do. This new way of thinking isn't just a cool philosophical idea. It's got real practical upgrades. It gives us new logical tools, these things called connectives, that let us compare what sentences actually mean, not just whether they're true. This gives us so much more power to talk about complex ideas. And what's really fascinating is it creates this unified framework that can hold a bunch of different logics all under one roof. And this unified framework idea isn't just talk. A lot of famous, non-classical logics, I'm talking about things like modal logic, which deals with possibility, or intuitionistic logic, which is a huge deal in computer science, they can all fit comfortably inside this bigger non-Fregean family. It's like a giant umbrella for all these different ways of reasoning. So if meaning isn't just about being true or false, where does it come from? Well, the answer is something we all get intuitively. It's all about the context. The situation you're in becomes the absolute key to figuring out what something means. This is the basic idea behind what's called situational semantics. And it's actually a really simple, powerful flow. You start with a sentence, then you think about its context, the situation it's in, and only then do you get to its unique meaning. The same words can mean totally different things in different situations, and this kind of logic finally knows how to handle that. And the implications of this are just huge. I mean, this way of thinking is so radical, it even makes us rethink something like mathematics. It suggests that those hard mathematical facts we learn about might not be absolute objective truths floating out there in the universe. Instead, they could be mental representations, ideas that exist inside our models of the world. That is a serious shift in perspective. Okay, so this whole journey into a new kind of logic has brought us to one final, truly mind-bending place. We've seen that non-Fregean logic is more powerful, but all that power reveals something strange and fascinating, right at the very edge of what's possible to know. And that brings us to this concept of undecidability. Now, this isn't about a question we just haven't figured out yet.
No, this is a question for which it has been mathematically proven that no perfect step-by-step process, no algorithm, can ever be built to give a guaranteed yes or no answer. It is fundamentally and forever unsolvable.
And this isn't just some crazy theory. There's a specific non-Fregean logic out there known as SCIQ that has been formally proven to be undecidable. What that means is, built into the very fabric of this powerful logical system, there are questions that no computer, no matter how powerful, could ever be guaranteed to solve. Ever. So, think about where we've been. We started by just questioning a simple true or false world, and we ended up at the absolute limits of what is knowable. It just goes to show you that even the basic rules we use to think have these incredible hidden depths and wild complexities, which really just leaves us with one final thought. If logic itself can be so profoundly reimagined, what other fundamental ideas are we all just taking for granted?